Hello, everybody. So we're into module 3 now, a quarter of the way done with the 8-week courses for the second term. A couple of things. One, we're going to pick up the pace a little bit. I was wanting to start off slowly, and I guess it ended up kind of slower than I'd anticipated. I'm going to switch my routine around and start drinking a whole Mountain Dew before this 6 o'clock class instead of half Mountain Dew. So I was drinking half a Mountain Dew earlier and then half Mountain Dew before this one. But things were going slower than I anticipated, and we didn't even get a chance to talk about loops last week, and that was what was one of the things objectives in the module last week. And it's probably going to adjust a little and go to pretty much examples to follow along. We'll just talk about things along the example. And that example that was that big situational example that we started instead of just a raw syntax example. We're going to keep coming back to that over and over again this semester to see all of the different things in place and how we would use those in this similar situation. So I did pick that based off, we're going to use that same example throughout the semester. We ran out of time to put a loop in it the other day, but obviously we need a loop to keep that running so we can do more than one person's payroll at a time, if you remember the example from last Wednesday. And then the next thing on the list is functions and file writing. So with functions, we'll be able to modularize that some, break it up into small manageable pieces. That's the content for tonight. Then on Wednesday, we're going to look at file writing, and that'll be very useful. So we just go for that payroll calculator example. People's names don't regularly change, right? People's names change when they get married. And please keep that in mind. I don't know if anybody in here has had to deal with it, but Ivy Tech system is exceptionally bad for that. In the American culture, women get married and change their last name. That's very, very common. Men can also change their name. It's the historical context was the women changed their name, but the software at Ivy Tech does not really allow for that. So I've seen a lot of people try to get their name changed, and they're not able to get it changed. They still have the maiden name on the email or something like that. And since everybody here is heading towards software development, or this is just a software development class, please keep that in mind that people do change their names, and keep that availability in the software you make, so that if people change their names, they can, like when they get married, the stuff in the computer system can update as well, like emails and logins and all of the different places a name shows up on the Ivy Tech system is very, very difficult to change when we get married, change your last name, or counting the time I was here as a student, and then after I graduated from Ivy Tech, he started going to IUS and was still working here, and then started here as an adjunct faculty, full-time faculty, and now department chair. And all of that time, I've only ever seen one person successfully get her last name changed from that. And she was utterly determined. She was utterly determined to not use her ex-husband's name after what he went to prison for. So she was on a mission to never see his name written down again. So I think it ended up taking 3 or 4 trips up to Indianapolis to actually go into systems office and talk to people, sit down at their desk, and all sorts of other things. But in over a decade around Ivy Tech, we had these 2 names on here. In over a decade around Ivy Tech, I've only ever seen one woman successfully change her name in the Ivy Tech system. And it took a while. Like it took almost the entire 2 years of her degree to get that name changed, because she came here like 8 years earlier. So her email still had the name from 8 years earlier. And she was just utterly determined to not see that name written down. And yeah, it took several trips to Indianapolis, countless emails, back and forth, different offices, probably a couple other campuses along the way before she finally did that. Says, this is a software development class. Y'all are going to be making software. Please keep that in mind. In our culture, women change their names. Men can also change their names. I see at least one Latino name on the screen. Remember, Latinos do it more often than not because it's also shown as a sign of respect to the families they come from. But people, names do change. They're not etched in stone. So please keep that availability in your software because it's something the users will need. It'll make them happy. So a little side grant there. For a couple more people came in. So we're going to pick up the pace a little, get into more example stuff. I was wanting to start off slow, and it's ended up slower than I thought. We didn't even talk about loops last week. We ran out of time for that. So I'm going to pick up the pace and kind of move more towards examples. And that example we started is going to be our fallback over and over again this semester, so that when we learn a new concept, we're going to tie it into that. I did specifically select that so we can modularize our code. And when we get to file writing on Wednesday, we'll be able to save that. And that's what started that little side step. Because people's names aren't going to change. So we really shouldn't have to enter somebody's name every time for the weekly payroll. The name's going to be consistent. Or like that little side step there, remember to leave the availability to change their name, but it's going to stay the same. Or their pay rate. We have to enter that every time from what we started last week. But how often do we get raises? Probably once a year, right? So there's definitely no need to re-input the same rate of pay every time we do payroll if raises only happen once a year. So that's a great example for savings. So we'll use that for saving data as well as printing out the list of pay stubs. So instead of going to the console, we'll actually print them out a text file in here, but theoretically we could send them any place. We'll look at functions tonight is the next thing on the list. And since we've been kind of slacking on the Python syntax, I want to jump into that. But please keep in mind, it's not a Python course. It's a software development course. Python is just the easiest language to use. So it's a great way to introduce the concepts. For example, one that's going to come up tonight, Python falls a little short on. And when we don't have anything, we'll use the term void when we're talking about it. You might hear me use the word null sometimes. In Python, our keyword is none. But in most of our programming languages, there's actually two things, null and void. They are a data type. They're not emptiness. We don't really have true emptiness in an electrical machine if it's turned on. If it's turned off and been turned off for a while so that all the capacitors are drained, then there's probably emptiness in the machine. But while it's on, there's not true emptiness. So null and void are actually data types. And you won't see them until you get up to asynchronous parallel processing. For a lot of people who don't see that till the mobile app development course will probably be the first place that shows up. And some of y'all might skip it there because there's a lot of other stuff we can look at. But further down the line, there is a distinction between null and void. And in Python, we only have one type that includes both of them. So there are some shortcuts in Python. Everything's automated in Python. So that's the biggest change from like this in my Thursday class. We're doing all this stuff in Python. To make it easier for the human, all of the stuff was moved to the background, which means we don't have control over it anymore. But if we're working in like Java, C++, or C#, we have control over all those things. So we have to set up all the configurations on how it's going to run. Multiple ways to, I guess the simplest example is the print statement, right? Hello world. But there's multiple ways that we can move stuff to a screen. Going to C++ as an example, we usually use bit shifting. So we'll have our standard out. We'll have our standard output, And then instead of a print statement, we just use bit shifting, which is 2 angle brackets, and then we'll have a character over here. So like an A, just a 65. So in binary 0001, we have this data. Oh, stop screen share so the video shows up bigger. And this symbol means bit shift. So instead of print, we're actually just going to shift these bits over to our output. And there's multiple ways we can do that. We can do that in serial or parallel, and we have absolute control over the machine. But that also adds into more stuff that we want to do. So like simplifications in Python restrict us to one and only one way to move characters off of the standard output, that console output. Makes it a lot easier, but we don't have alternatives. We have to go reconfigure Python and the Python language entirely. And then that's probably going to mess up some other stuff we've written in Python. So there are advantages and drawbacks to everything. But Python has a lot of simplification, so it's a good one to introduce things with. But in some of our other languages, we have a lot more control over what happens. We have absolute control over what that machine is doing. I wrote C++ code on the board. C++ will never throw up an error message. If we write some code that will make the machine self-destruct, it will just self-destruct. At least in Java and C#, we still have that ability, but we'll get a warning message. We have to actually ignore a warning message to self-destruct the machine. Different things we can do everywhere. The big thing is all of the languages have different things that they are optimized. So we typically do not work in a single language. Obviously, that would be very, very confusing while learning. So we minimize it, and very rarely will we work in more than 3 languages at once in a classroom. When we do file writing on Wednesday, we might see, I know there's some database people in here, there's some networking people, so we'll probably look at using SQL instead of just a text file, because seeing how to put SQL in Python code will probably be more useful if you're a database person. Actually, it'd be more useful for everybody, but actually seeing the language to control a database embedded into our Python would be our first example of using multiple languages at once. And that's how we usually write code. We pick and choose the optimal language for a particular situation, and then mix and match those pieces. So overall, we're getting the best from all the different languages and ignoring the low. We only grab the high points and ignore all the low points to optimize our software. I want to point at some things, so I haven't had a whole lot of syntax examples, so I'm going to open up that example that we started last Wednesday, which I think I deleted locally. Yeah, I cleaned up my machine over the weekend. It is on GitHub. We'll be looking at repositories. You have an assignment on that. Your final assignment has to be returned in as a repository. So you just have to tell me where the code is set up. So it's on over, what class is 140? SDEV 140 fall 2022. So it's right here. You can download the files, or I'm going to do that a little bit differently. Close out of this and kind of point to the reason we do that. So I'm just going to open up my terminal, and this one won't really be expected in the class. I just want to do an example of the difference between that and Google Drive. Because we're just storing stuff online, we can use Dropbox, Google Drive. But the thing is, those don't connect directly back to our terminals. And I know the 2 people who study networking in here are already thinking about SSH and RDP. But we have to do a whole bunch of extra things. We have to do special connections between the machines. Whereas if I just type Git, as in GitHub, that most popular repository in the world that I just pointed out right now, and hit enter, notice that's not an error message. So the name GitHub comes because that is an instruction in our terminal. In every terminal, it was invented by Linus Torvalds, so guaranteed it's in Linux, but it's it's way up there among the top things he invented. He always names things after himself. Git is Old English. It doesn't stand, it's not an acronym. It's Old English for an unpleasant gentleman. We don't really have a regular word in American English we use for that, but there's a B word for women, but the male equivalent of that. Britain has a word for both males and females. But he names stuff after himself, and he knows that about himself. So in our modern world, most people are more than willing to tolerate it for a chance to work with Linus Ronaldo. If you don't know his name, you will.
Craziest content I've ever shot in my life. This interview is whiskey, and Baloski. Ladies and gentlemen, so this beautiful lady here, I was passing through when I found what I said.
Can't quite hear you. Were you talking to somebody else? I think he just didn't realize he was unmuted. Okay. Sorry.
Sorry about that, please.
Okay, I thought you were talking to somebody else. It sounded like you were looking away from your microphone, like that muffled sound. So I was like, I think he just doesn't realize you unmuted. But yeah, Linus Torvalds, he invented Linux. So his name's big in the world, and people will tolerate the fact that he's a notoriously difficult to work with, and he names stuff after himself. So that's where that term comes from. So if I change to my working folder, documents, and delete folder, there's just a folder in there. So if I make a new folder, make I'll call it Git stuff, and go into that, then I can just use that command here. So git initialize dot. Dot always refers to the current directory. So if you need to refer to the folder you're in, that's dot. Some of y'all may have seen dot. So the folder you're in, and then go up to the parent one. So use that command there, then git remote add origin. I just happen to know what this is. https:// github.com Francis-Chris 5 /SDEV 148-fall 2022. So that's what you would put in the URL in the address bar, so you can just go there and hit the green button and download the files. Here in the command line, you do need to add the .git extension. So I added this origin, have all that stuff there, and then I can do git full origin on the main branch. We can have multiple branches, so we can have several versions at once. If you're on Dropbox and upload a new thing, your backups might have a different version you can get back to. But we have several different versions running at the same time, lots of different things. If I do this, it'll just grab all that stuff and bring it down. And then I can push it back up to that repository from someplace. You can always pull code down from the repository, or just copy it down to your computer, but you have to have permission to push it back to the repository. But it's the big thing is that Git from the name GitHub it's not an acronym. It actually comes from an instruction we put into terminals, and that will be on any terminal you have on any system. If it's a computer, it knows the Git instruction. So repositories are a little bit more than just storage. But now I have all the files from that. Well, I grabbed the wrong one. Let me delete that. Let me try that again with the right repository. I grabbed the one from the afternoon class. So I'll make a directory to put them in. I'll just call it Git stuff. Go into that and initialize it. And git remote add origin. And I like to do this stuff in class to see this because we will be having to do some command prompt stuff before long. Go back on. Five, and then ours is SDEV 140, not 148, fall 2022. Get full version, right? There we go. Now hopefully it has the right files, yeah. So here's, so far it's just that big example. And we can do multiple versions, we can get back to any version. Things aren't gone, they're always still there. We have complete control over the file storage. Not just the current version, alternate versions, past versions, all that stuff. So if I open that up, I want to point at some syntax things before we move on to the next section, which you all have all seen. So here's that one we saw last week and our basic usage. So assign in a variable. It's open type language. Let me read off the thing. So in the history of Python, there's a couple different history versions you will see when you go start looking into it. And the original one, he kind of tried to slide back to the side. Those notes. Here it is. So it was December 1989. Fellow named Guido von Roosum. He found himself in a situation where he could not get out of a family event. A family reunion, Christmas time, that's really standard. But he didn't want to go spend the time with his family. And he couldn't get out of the event. So what he did is he made up a project so he could get out of talking to his family. And this is just those few days there in December of '89. And he came up with this project and he had to tell him what he was working on and stuff, because obviously his family reunion, they're not going to stop talking to him. He has to sound really, really busy so that they minimize that talking to the family. And what he described was a programming language, open type, a general purpose, object-oriented language is open typed with significant white space. So at this point, most of those words probably makes a lot of sense. We haven't seen object-oriented yet, but general purpose, that's going to make sense. Open type means we don't have to say what type it is. So we have strictly typed languages, and in those are definitely the fastest because the programmer tells the computer what type of data it is. So if we want to store an integer in a variable, we say we have integer data, and then the CPU only gives us enough space in RAM to store an integer. Alternatively, we have like open type languages like we have here in Python, where we don't have to say what type it is, but we do have to stick with that type. Like we can put an integer or a floating point number or a string or any of them in there. We all have probably seen that cause issues when we get down and start concatenating together in strings. Because once it does still have the type, we just don't have to say what it is. The computer, and once the computer figures it out, the computer can't automatically change it back to a different type. So we don't have to say what it is, but we have to stick with it. There's also loosely typed languages, and in those, we can switch and mix and match our data. Really, it's treated as there's only one type of data. So PowerShell that I just had opened is like that. You'll recognize those because the variable names always start with a $sign. So like $price equals $12.99. And then when we need that again, we can do math with that. 2 times price. The variables always start with the $sign. And notice when I was saying that, I said price, not $price. There's really only one data type. We call them resource. We call them resource. So it doesn't matter whether we have an integer, a string, a single character, an array. They all count as the same type of data. Which makes it advantages and disadvantages to that. They're easy to spot though because of the $sign, so we can do math like we would in any variable. The nicest thing about those is if we need to concatenate them, we don't have to worry about type. We don't have to do anything special here. So notice I didn't break out of the string and concatenate it together. I didn't put any special symbols. I just threw that variable right into the string like it was another word there. That's the nicest thing about loosely typed languages. We're gonna look at PowerShell later this semester because everybody should see that. This will work on all of your systems, but that's a loosely typed language. There, we don't have to worry about the type of data at all. In Python, we don't have to say what it is, but we do still have to worry about it. And in strictly typed languages, we have to say what it is and keep track of it at every point along the way. Significant white space, there's probably not much here. I will add some in here shortly when we get to revamping this. But I think everybody in here has probably seen an indentation error with it by this point, right? Instead of curly braces, that's how we used to block out lines of code. So maybe if we had an input function, which we're going to write this evening, instead of those lines all go together. So in like the C family of languages, we would use curly braces, surrounding curly braces, and that indicates that that's a block of instructions that always goes together. We can't really pull one instruction out of that block. We have to work with the whole block. So for Python, to get rid of the curly braces, you just end it. And went with the human natural and significant white space. Humans, a semicolon in the C family means end of instruction. Technically, it means next instruction. Y'all probably notice that computers read right to left because we write, not left to right, not the way the text goes. We can tell that because lines like x equals x plus 1 work. It does the right-hand side first and then goes to the left. So the computer's not reading that left to right. So the semicolon end line technically means next instruction, but if we read it that way in the file, in the text file, it doesn't make a lot of sense. So we usually say end of instruction because it still applies the same way logically. So semicolon is end of instruction, but that's not how humans end a statement, right? If we're typing, we end a statement by hitting the enter key and going to the next line. So he did that in Python. The significant white space is just a line break instead of a semicolon. It's dynamically typed, garbage collected, and interpreted language. So those things, significant white space, object oriented, significant white space, open type, or dynamic, open or dynamically typed. It'll be a couple weeks before we can really describe the difference between those clearly, other than just using the word, saying the words are almost synonyms. And if you're just speaking to somebody, they're synonyms, but if you get into the real technical details, there's a slight difference, that sort of thing. Compiled and interpreted is how the code runs. So in interpreted language, it runs one line at a time. So here in this code, it would grab line 1, grab a line 1 from here, translate that into bytecode, machine language, something the machine can work with, and then send that one line over to the interpreter to be run. And after that, it comes back and grabs the next line, translates that into something the machine can work with, sends it to the interpreter, and runs the one line of code. A compiled language creates an entire file. So it would read all of the instructions, the entire file, translate that into machine language or bytecode or something the machine could work with, maybe assembly language. And then you have an entire file of instructions that all get passed in to run at once. The biggest difference is a compiled language, if there's errors, especially syntax errors, it will not compile to begin with. So you can't create that file to start running. But with an interpreted language, it's one line at a time, so it's just going to start at the beginning and run every line of code until it hits an error. So the errors behave differently between them is a good starting point on that. And yeah, it started as an excuse to he couldn't get out of the family reunion, so he made up something that would make him sound really busy so he could get out and talk to him. And by the end of the weekend, he realized he was onto something really, really good because he was sitting there He didn't actually sit there at his computer working, typing and making it. By the end of the weekend, he realized he was on some breaks. When he got back to work, he told his coworkers about it. Yeah. 1989. By 2017, it was the most popular programming language. And it's really, really looks like it's going to stay there for a while. So it turned out to be a good thing, but he's kind of that original story's been buckled around a little bit. Not changed, but they hit some of the details. Like the idea was so that he could get out of talking to his family. They kind of took that out of the Wikipedia page and said he had 3 days to work on a project. The polishing it up, making it sound better. He was a computer person. He had the social skills of a computer person. People in here probably understand that. But our general syntax, when we have a variable, we just put that variable in there and throw in the value we need and start working with that. You all have seen that a few times. I use that shorthand notation because that's not written in the book. Remember, if it's a short if else, that's just going to be an assignment on the same variable either way. We have this ternary operator where in parentheses we can write what happens if our condition is true, a comma, and then what happens if our condition is false. And then right after the parentheses, we put in square brackets the condition we want to run. That's equivalent to an if-else statement, but I want to go ahead and write the if-else statement. Yeah. If our, how was this spelled last week? If hours work is less than 40, we're going to do this stuff. Otherwise, we're going to do this stuff. So you can see the same, I'm copying and pasting this. We're doing the exact same thing. It's just a difference in syntax. And when it runs through the CPU, it's going to be exactly the same, almost exactly the same. If I type it correctly, gross pay equals that, or gross pay is assigned that. And I wanted to retype it this way to talk about that structure. This is how you all are probably writing your code, right? For those who have turned in homework so far, that's what I've seen. The if-else structure, not the ternary operator. I just wanted to make sure you knew that existed and it wasn't written in our textbook. But we'll probably do things like this and this structure. We have a keyword, one of the special keywords in Python. And then we have something unique to our situation. And the if, when it goes by the if block, that unique thing is our condition. In this particular case, if hours worked is less than 40, we don't have to pay overtime. If it's exactly 40, it wouldn't make any difference at all. Because that little bit extra would just be 0 times the time. But if anything past 40, 40.00001, and the pay increases. So we need to have that special situation, the thing unique to our situation. And then we have a colon. And following that is our block of instructions that are indented over. That is what I think of as the general syntax, general Python syntax. We're going to see it again when we talk about functions tonight. Or that thing we didn't see the other day. Might need something like exit equals false. Start with exit program equals false. And then while not exit program, then we'll do all of this stuff. Oh, I think I have to write the word not. Trying to do C stuff again. We have to actually write the word not. It is just a bang and or other things, exclamation mark. to make exclamation mark is a lot of syllables. So if we call that a bang, it consolidates that. So then I'll indent all that. So once again, that same generalized syntax, right? We have our keyword while, which says what we're doing. And while means we're going to repeat a loop over and over and over again. We're going to repeat this over and over and over again, just keep doing it until that exit. And our condition this time, our unique situation is not exit program, which exit program is false. So not false is true. Basically, I just wrote an infinite loop there. Just going to keep running forever, right? This is what we ran out of time for the other day. It's going to make it seem more like program. So I'll not exit, we'll go through, grab somebody's name and hours they work, what their rate of pay was. And when we get to files, writing files on Wednesday, then we can cut out 2 of those lines because their name and rate of pay aren't going to change. Or at least not often enough that we need to type them in every single time. Then we'll check how much they should get paid, do that calculation, and print it out. Which for our thing here, I'm gonna take this. We don't need to print the label every time. I'm gonna move that up here before the loop. Because we only need 1 label on our table. We don't need labels every row. And then I'm gonna add a bunch of dashes, which I thought there was, just to format the table nicely. I'm pretty sure that's what that line was for. So it'll print the headers for the table. Then we start getting employee stuff, calculate their things, print out their thing. Then afterwards, we can see if we're done yet. I'll create a variable called next user. And that's going to be some sort of input from the user to keep the program going. We probably want to put a lot of thought into it, but since we're short on time in classroom, I'm just going to do something simple. Is there somebody else? Enter yes. Oh, whoops. Actually, I'm going to type that. Yes or no. And do you notice the problem there? Because when I'm asking for that input, I'd like those quote marks to be there explicitly. Those are where escape sequences come in. So we saw tabs. I thought there was a new line here somewhere. \n would give us a line feed. \r would give us a carriage return. So a line feed, and in the old days of typewriters, that carriage, a line feed is just rolling that wheel. So we go to the next line, but we're still typing in the same spot. A carriage return line feed, we roll the wheel and move back to the beginning of the line. It usually doesn't matter in computers, but there are situations where it does make a difference. OneNote, if anybody's ever used OneNote, that would be one of those situations because like in the text file, when we go to the next line, there's nothing there. So the only place we could be is the beginning. But on OneNote, there's just a big, large working area. So if we just do a line feed to the next line, we're way over wherever the previous line ended. So there are situations where it matters. And if we need special characters like this, that's why we actually call escape sequences. Quotation marks mean something in this situation. So we need a \/ to escape out of our code and explicitly type that symbol. So escape sequences are escaping out of that. And for a tip, what I usually like to do is go ahead and type out a line with all of them there, and then go to the end of that line and put your \n for escape sequences starting at the end and working towards the beginning. Because as I do this, you'll notice the colors are still wrong. When I come back, when you go this way, it corrects the color coding as you move towards the beginning of the line. So when you get back to the beginning, you can tell that everything was corrected, because going forward, it's going to constantly change back and forth depending on where the quotation marks fall. If you start at the end and move backwards, it's like, it'll correct your color coding along the way. Those little tips work in there.
Question, please.
What was that, Joseph?
Yeah, question, please. I thought less than 40 is not the same thing as less than or equal to 40. Is that correct?
Couldn't really hear you there.
Let me increase my volume. Less than 40 is not the same thing as less than or equal to 40. Is that correct?
That is correct. Less than.
Okay, so if we're saying less than 40, that means if someone works like 39 and a half hours, then it's still gonna be.
Yes, because we have different things there.
So I think
Right? We have like 39.9999. Right below 40, so that less than 40, however many nines we want to write, we can write nines forever. And we're not quite to 40 or something really, really close. And then right past it, we have 40.00000. And eventually somewhere down there, we'd have a 1. Because we are a little bit past 40. So there's only that one spot exactly that would be exactly 40. So less than, exactly equal, or greater than. There's just that one spot. It is, but yes, to answer your question, it is different. And in this situation, I just ignored that difference because if it's exactly 40, then that overtime pay will be 0. So we throw a 0 into our equation for how much overtime.
right.
Because we're 0 past 40, so we just get the regular hours. So a shortcut in this case, but it probably would in general be better to actually write that.
Okay.
But is that clear what you were thinking about, Keith? I thought Joseph asked it first. So now we can ask for the next user and then we just see what that is. I'll do it in an if else again. So like if next user, which is the word yes or no. But I'm coming down to the next line. Can we really trust our user to type yes with capital Y and lowercase e and s? Right? There's lots of ways we can type yes. It could be yes, 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 yes. All sorts of different ways we can type that word. So we could use or to check a bunch of things, but an easier way would be to handle it all at once. All of those different capitalizations, what I'm gonna do is just check them all at once. So if next user dot, and we have methods upper, which would turn them to all uppercase, or dot lower. Anytime we have a string, we can do a dot upper or dot lower and make it all uppercase or all lowercase. That makes our conditions a lot easier to check. Then we don't have to check the different capitalization. They all have the exact same thing. I'll go with dot lower, and it's a method, so we need parentheses, or sort of our standard symbol for do something. If it's just the word, it's a variable. It's holding a value. If it's the word and parentheses, it's a method. So a method, we're gonna talk about that in about 10 minutes. We started talking about those about 10 minutes from now. But a method is like a variable that holds instructions. So if we just keep using the word, it's only those instructions that we're holding. So we can rename them and things like that. And when we put parentheses on them, that's like saying, go ahead and run that. Go ahead and run those instructions that variable is holding. So if we make it all lowercase, then we only have one thing to check. Then, so if they say, is there somebody else, yes or no? Actually, I just want to check no. Because if there's not anybody else, then we want to change our exit program to true. We'll say exit program is reassigned to be true. So then when it comes back around our loop, not true is false, so we jump out of that loop. There's two main types of loops, while loops and for loops. And our general rule of thumb across the board in all our programming languages is while loops are for when you don't know how many times it's going to run, and for loops are for when you do know. For loops are for iterable or countable things. And just because we say it's countable does not mean that we know the number. We say it's countable, and it could be 7, it could be 17, it could be 7 million. What we do know is that there is definitely a beginning and definitely an end to it. That's what countable means. It's possible to count it. We don't know or really even care what the number is. The computer will count if we're doing something countable in the computer. We know there's a definite end. So that's when we want to use a for loop, when we know for certain how many times it's going to happen. A while loop, and obviously they're interchangeable. Go with the one that makes most sense in your mind, or whichever one you remember, just kind of with what flows out, especially to start with. But a while loop is for when we don't know how many times it's going to happen. So we think about like IoT devices. Think about your thermostat. Your AC is going to kick on when it gets hot enough. So while temp is greater than 72, the AC turns on. Do we know if the temperature is going to be when it's going to drop below 72 so that the AC turns off? Or do we know if it ever will? In July, it might never drop below 72 and the AC just runs 24 hours a day that whole month long. In January, it'll never turn on. So we don't know when that condition is going to be met. We just have to set up the conditions. That's when we want to use a while loop. Use a while when we don't know how many times it's going to run, or if it's going to run at all. Think about a thermostat. That temperature, we know the condition. Above or below 72 is going to adjust between air conditioner or no air conditioner. And then again, when we get down to 65 or something, we switch from no heater to heater. So there's those conditions in there, but we don't know if we're going to hit them. We're probably going to hit them today, right? Today's temperature here in southern Indiana ranged from, well, it was a little chilly early in the morning, but in general, it ranged from like 66 to 71. So most people's neither the air conditioners or heaters turned on today. So that's when a while loop is for, when we don't know when or even if it's going to happen. And a for loop is for when it's countable. We know exactly how many times it's going to happen. Y'all are probably used to seeing the for range. You've probably seen that. So like for I in range, like 12 things, or we can throw in some other parameters to start, stop, how many steps grow each time. But that range function is fairly new for Python. We didn't have that for the first 25 years or so of Python. So for loops were usually for something else. A for loop in Python is really what we would call a for each loop in our other languages. They're for arrays, for each element in the array, and then we just walk through that. We don't even need to count them. We don't need a number there. We're going to grab them one at a time. And when we get to the end, we're done grabbing stuff. Or lines in a file. For each line in a file. That's where the files naturally split up, since that shows up this week. And we'll grab each line in the file until we get to the end. And we don't need to count them. We don't need a number to correspond to them. We'll just grab that thing for each line in the file or for each element in the array. That's what for loops are really for. But we can use them both, especially since they added the range function. You can either do a counter loop in a while or a for each in range. Different options. A lot of that comes down to your style. So just mentioning the general rule of thumb. And I think this will actually behave like software now, which I haven't had saved yet. So I'm going to go to File and save as payroll underscore. Well, it's still kind of the first version. We haven't revamped anything else. And in the loop that I wanted to do last Wednesday, but we ran out of time. So 1.100. I'm going to leave off the dot because the dot means something to computers. So Let's think about when we write it with a dot in text files, if it's something the computer's gonna read, like a file name, it's better to avoid that dot. Because like in the file name here, the dot goes with the Python. The dot is what tells the computer this is a Python script. So maybe all those lines, or sometimes you'll often see with underscores, different things, but especially starting out here, because you may not know every place that matters versus doesn't matter. I would say just avoid the dots. Do like your version, release, patch numbers like normal. 100 was the other day, so we're on 101 now to keep those straight. And even though we would say 1.0.1, just looking at it, but let's just avoid the dot for now. Actually, that's the current state of that's not going to work because the label's in the wrong place. So I'm going to crash that run. And for now, I will go ahead and print the labels every time. And I'll add an empty print statement at the end just to add some extra lines. Let's see if that looks better. So we get the first person's, we get their name on there. Just making up some names. So Sally makes $12.34 an hour, works 34 hours. And it comes back around. Oh, I just made a silly mistake while talking. This is how programming normally goes, right? Y'all are used to the, most of our class examples are going to seem different than the normal format because of preparing things ahead of time. But even though I knew what to do to fix it, it still made a typo. That prompt was supposed to be an input, but when I went to fix it, there's a typo. That sort of stuff is kind of wasteful in the short amount of time you have. That's why I usually practice heavily ahead of time.
Please, before you go, still on that line 40, you have a double code at the end of node. So one is for the node, then the other one is for the entire line, right?
Those
Okay.
two characters right there count as one symbol. Escape sequences will always look like two characters, but it's only one character. We just need two symbols to write.
Okay.
That makes sense, Keith?
Yes, yes.
Yeah, that is a great question because that is that throws us off. Those two symbols are one character. That's how we write a quote mark inside of a string. So let's try this again. Hit run, and maybe there's somebody named Sally. 1, 2, 3, 4 per hour. Oh, whoops, 12.34 hours, and she makes 12.34 per hour. Is there somebody else? Type yes. Maybe put a colon and a space there to make that prompt look a little bit better. Somebody named Bob, who worked 34 hours and makes 43.21 per hour. It's a whole lot more. So it's still working like it did, and it keeps working now. It feels like finished software. In your SDEV 120 class, it was really late in the semester before things actually felt like a piece of software you could keep running. Right now it's menu based. When we talk to GUIs, I'm going to keep coming back to this example because it's going to provide an example for everything we're going to see in this class when we look at all the different stuff, list, files, all of that. I guess to print one set of headers we won't really be able to do that until we get to arrays. Because then we can add things to arrays and then print them out afterwards, after we get all the information. Or adding to files, and we'll be able to clean it up a little bit more. But we'll keep coming back to this example because hopefully the logic makes sense. And the thing I wanted to point out was this particular, what I call the general Python syntax. Because the way the book, the way our textbook shows writing files is not the best way to do it. There's something that follows the general syntax, that's for Wednesday. But we have our keyword, followed by something unique to our situation, and then a colon, and then we indent all of the stuff that applies afterwards. So that's what I think it was, the general Python syntax. And the next thing we want to look at would follow suit. And that's modularizing our code. Let me draw a picture on the board because this one does go nicely in pictures. We have basically one file. I'm going to draw the flowchart for a picture, but we have this one big file. We start here, and it just kind of goes through those lines of code and ends here, right? And that's what it does. We have a loop in ours, so it's going to go back around every time. But then the same thing happens over and over again, and it's all in one big file here. I guess I could draw it as a flow chart, right? We start there, then we have a some sort of loop where we either exit the loop or come back around, all of that stuff. But the same things are happening each time. And it's all in one big collection, kind of like the big rectangle here. It's not really much we can do for organizing that or reusing things, doing the same stuff over and over again. So what can be really nice is to break that up into pieces that are very generalized so we can reuse them in different situations. And I'll just kind of draw some marks like that, break it up into pieces. So then instead of this one big box here, we have these 4 separate pieces. How to draw something like this. I guess that corner is down there, and then one over there. So we have 4 separate pieces, so we can mix and match them, put them in different orders, reuse them over and over again. And it gives us a lot more power or other advantages when we go to start debugging it. If there's a problem, we know exactly which piece to go to. We don't have to dig through the whole thing to find it. That's where functions come in. So we're going to look at, I guess, first off, our basic syntax for a function. Follows the Python keyword. Keyword, and that basic Python syntax, the thing unique to our situation, which for a function is what are we going to call a particular set of instructions. So you can think of it as a set of instructions stored in a variable. So instead of just one single data point, we have a whole bunch of instructions stored to that variable. So if we want those instructions to run, we would do it when things go together. So that every time we run one of those instructions, we're going to run all of them. It gives us just like one quick way to ask for all of them at once instead of retyping. So we need some sort of name for our function. I'll just do a quick first example, double. And well, from that name, double, sounds like we're going to grab a number and make it twice as big. Just sort of do something with it. So we'll need some sort of number passed in. And that's a parameter at this point, because there's no value to it. It's just a placeholder. It's a spot because we know when we actually run this, we're going to have a number to pass in there. And when we do that, it's called an argument that we pass in. So parameters accept arguments. Arguments fill parameters. When we call a function, we send an argument. And when we design a function, we place a parameter for arguments to be passed to at runtime. It's important to know that distinction. You will most definitely be asked multiple choice questions about that. repeatedly along the way. It's another one of the little distinctions. I already said function a couple times. We don't actually have functions in Python. The functions and methods, when we're talking, just in general conversation, we will use the words interchangeably. Pretty much everybody does. But there is a technical difference. So when you're answering questions on a quiz and for like certification exams to get certified in Python, you don't get a Python certification by writing Python code. You get a Python certification by answering multiple choice questions. So for that, we need to know the technical differences. And functions are for procedural programming and methods are for object-oriented programming. And while it doesn't look like we're creating a new object here just yet, it will in a moment. Actually, it's almost after a break, so it will a few minutes after the break. But it there is everything we do in Python is an object. It'll make more sense after the break. You've already done it, but just going over through the steps of it. So our Python stuff, so it is an object, so it's a method, not a function. We don't have functions. Functions are for procedural programming. So like COBOL and Fortran and some other programming languages that you would see the name of in history books. But object-oriented programming is better for the human. So much better for the human that we don't really have. We use some object-oriented programming languages like Python to we use object-oriented programming in a non-object-oriented fashion to introduce programming, like Python, the first couple weeks of programming classes. But it is an object-oriented language. That's one of those key descriptions. It's not a procedural language. That is a question that you will be asked along the way. So just remember, we do not have functions in Python. We only have methods in Python. Methods go with object-oriented programming. Functions go with procedural programming. So now we need to do something with this. So I'll make a variable called D. And this is a local variable. I created it in here, so it only exists inside of this little function. And this is what the class is going to get back to. I stretched out the terms at the beginning. Eventually, we're going to get into this. There was still some more yellow pages and notes. I was like, instead of writing a bunch of stuff on the board, and we'll just do some examples. Good to follow along the examples, or it's an active subject we learn by doing. That's why our class doesn't go until 8:50 every night. We did once because we had to squeeze a whole bunch of stuff in, and I wanted to do that in one night so we get to the fun part of writing code. But it's an active subject we learn by doing. So in general, you want to follow along the examples or recreate the examples later. Or in all of my programming classes, I always like to do something slightly different than the instructor. That way I could confirm that I knew what was going on because mine was different. It wasn't an exact copy. But at the same time, I tried to stay close enough that I could ask a question if I got stuck. So we need to do an assignment, and from the name of this method, you can probably tell what it is. We want to double that. So double is just times 2. So we throw our math in there. And then at the end, this is what makes our 2 types of functions. We have void functions and return functions. So void functions just do something, and return functions send stuff back to what called it. So I'll say return P. So we actually return this value. And now to run it, we need to set up our guard. This is the next thing I was going to type. I could show better if I open this in. If I open this last one that we just did over and let me do that before I'll do that after the break. So I'm going to type the guard, GUARD. That's what we call this because it's something we always want to check before we just run stuff. We'll see why in a little while, but we want to make sure the code that is in that text file is the one we want to run. And to check and make sure we're in the right place, you always want to type this on your Python. Every Python file you write, .py, the very last couple lines near the end should always have this if block. We don't really have an else block. If underscore, that is 2 underscores. And in fact, we often call that a dub. So I might call that, you might hear me say that word. If I say a dub, that's underscore. It means something very, very specific to a computer. It is not random characters they chose. When we start with an underscore, that means something very specific to the computer. And when we follow it up with another underscore, that means something else very specific. We'll talk about what that means before long, but a dub is not a random choice of characters. That is a very specific instruction to the machine when we say underscore. We'll talk about that before long. And when they wrote the guy that wrote Python just added 2 at the end to make it symmetric. I guess he thought the code looked better at a glance if those key points were symmetric. We could see both of them. The 2 at the beginning make a difference. If that is equal to the word underscore main, 2 underscores again. So name, the 2 underscores, the dub name, that's how we would say that. The double underscore, then the word name. The thing we actually push the run button on when we go up and hit that run button, or type the command to run a program or whatever we do, the file that we actually start with, Python renames that file main. So we only want to do certain things if it's in the file called main. Because right after the break, we will see the next step to this. And if so, then print whatever the result of that double method is. That's in 4, so I'll go ahead and save this. Or in the delete file. This is a trivial example. I'll send a syntax example. I'll send it out later. I don't know why it closed out of the save thing. I have to save it before I can run it. I meant to just go up a file and save it someplace not in the GitHub repository yet. Yeah, so this folder is permanently linked to that website. So I can put it in this folder and have it back on that website already. It's not live time synced. It's not synced, so I have to resync it manually later, which obviously that can be done. That can be done right in Spider. There's a button in Spider that says Git, but I don't think we'll get a chance to look at it this semester. But I don't have to go through the regular file explorer. I can go to Git, put Git right into any IDE. This will be, I need a good name. My methods. .py. Now I can run it, and like expected, it's going to print out the twice as much as 4. That guard will make a difference after a break. We'll see why. It's been over an hour though. It's probably a good time to take 10, right? So, but notice this is important. So this is just the general syntax of Python, which y'all probably already seen. I just want to focus on it one more time before we step away. Keyword, something unique to our situation, a colon, and then we indent all of the stuff that we want to happen for that part. Or down here, keyword, something unique to our situation, and then we indent all of the stuff we want to happen. And then right off the bat is the reusability. So double 18 or print double 1. And we can get twice as much as any number really, really quick without having to rewrite all that code. We can reuse it. That's our first advantage to it. Debugging is also nice because, bug shows up, we can jump, we know exactly where it happened because everything's in small pieces instead of a great big piece like we have over here. The whole file is one thing, but here we have lots of small pieces, so we can jump right to that small piece. But 10 minutes sound good to everybody? I see head nodding in the class. Okay, with y'all on a Zoom call. So my laptop says it is 7:14. So we will get back to it at 7:24. On my laptop, so if your clock says something slightly different, 10 minutes from now.